Mathematics often deals with measurement, perhaps the most basic measurement being length. We can use length to measure the distance between objects, and let's look at this in the context of numbers. For example, what's the distance between 1 and 4? We count the units between these two numbers on the number line, and we see that there are 3 units of distance between 1 and 4. Similarly, what's the distance between -3 and -1? We count the units and see that there are 2 units of distance. Note that the signs of the numbers are irrelevant. We only care how far apart they are on the number line. The distance, therefore, is always positive. This leads us to the definition of the absolute value of a number. The absolute value of a number x, denoted by this notation, is the distance between 0 and x. If x is greater than or equal to 0, then the absolute value of x is simply x. But if we take, for example, x equals -3, then the absolute value is 3, since -3 is 3 units away from 0. In this case, the absolute value of x equals -x. In general, the absolute value of x is x if x is greater than or equal to 0, and -x if x is less than 0. Note that if x is less than 0, then -x is greater than 0. Don't be fooled by the negative sign into thinking that -x must be negative. To graph the function f of x equals the absolute value of x, we can proceed as with any other piecewise defined function. Let's start with the graphs of x and -x. We want the graph of x only when x is non-negative, and we want the graph of -x only when x is negative. So we end up with this, the graph of the absolute value of x.